Alright, problem 1. Verify that this is not an identity by finding an x value for which left and right side do not equal each other. So if I'm going to call y sub 1 my left side, and y sub 2 is going to be the right hand side, so I want to identify that on my paper. I want to make sure my calculator is set to radians, not degrees. So you can see right now it's marked in degrees. So I'm going to go right here and change it to radians. Enter my equations. So sine of x cubed is how we type in sine cubed of x plus cosine of x cubed. And on the bottom I'm going to do y2 parentheses sine x in parentheses for the sine, not for that first expression, plus cosine of x in parentheses. That finishes the first expression in parentheses. And then times, and then 1 plus sine of x in parentheses, cosine of x in parentheses, in parentheses. So make sure it's all typed in correctly. And if we just compare the graphs real quick, if I just did a zoom 6, that should be sufficient to see that they're not the same. There's my first graph, sine cubed plus cosine cubed. The second graph in red, very obviously not the same graph. Now what we do is find a single value of x where they aren't the same. Take your pick. Just looking at the graph, looks like 1's a pretty good candidate because they're way away from each other there. No doubt whatsoever they're different than each other. So let's just go with x equals 1. If I go over here to my table, got a whole bunch of different things here. You can see same at 0, different, 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 different. Take your pick. So x equals 1. I can see that y sub 1 is 0.75, 36, and y sub 2 is 2.01. 0.00999, so we get 2.0100. So I suppose that would be my answer to that. Tell me the x value you used, tell me what y1 and y2 are, and tell me what your values were that were obviously different values. Number 2, verify this identity. As I've talked about many times in this section, pick the side that looks uglier. In this case, this side looks like it's got more stuff going on. Left-hand side is really simple. Right-hand side isn't so much. So I've got cosine squared of x on top over 1 minus sine of x on the bottom. And I will allow you to use your trig identity sheet, this one on the test, so you get the proper numbers. But that's the right-hand side. So if you do any kind of trig substitution, I would expect you to use this sheet. I'm going to use number 7 first off. Notice that cosine squared is the same as 1 minus sine squared. And I notice 1 minus sine squared is a difference of squares, perfect square minus perfect square, so 1 plus sine of x times 1 minus sine of x over 1 minus sine of x, and that's by factoring. And then of course, oops, write the stuff down correctly, 1 minus sine of x on top and bottom canceling with 1 plus sine of x. That's by canceling. And there's your verification. Number 3, find the exact value of sine of 240 minus 45, and this is just sine of a difference of two angles. It does say exact value. They subtract to 195. That's not one of our numbers that we have an exact value for. So if I use the sine of a difference identity, it tells me that I take the sine of the first angle, cosine of the second angle, minus, and then cosine of the first angle, and sine of the second angle. And then sine of 240 degrees is negative square root of 3 over 2. Cosine of 45 is positive square root of 2 over 2. Cosine of 240 is negative a half. Sine of 45 is the square root of 2 over 2. And just like that, we get negative the square root of 6 over 4 for this. And we get positive the square root of 2 over 4 for that. So the end result, exact answer for this problem, is the square root of 2 minus the square root of 6 all over 4. And you should expect these two angles to be specific numbers on your formula sheet that you have sine and cosine values for. You'll have to use one of your sum or difference identities. I could just as easily say cosine or tangent for that, so just make sure you're comfortable with all three of those sum and difference identities. Number 4, 5, and 6 all relate back to these angles alpha and beta, and I'll do that on the quiz too, just as a time saver. This first step, where we have to actually find the sine, cosine, and tangent of alpha and beta, it's kind of overkill to have you make you do it several times. So I'm going to make you do it once, you get your alpha and beta, and then you'll get your stuff from that. We want to make sure we do this part right. So quadrant 3, I'm going to draw that. So quadrant 1, 2, 3, 4. Quadrant 3 is right here, the one I've really focused on. So negative 3/5 is sine, so let's maybe go like that. And then if I were to draw a line directly to the x-axis like so, at a right angle, alpha is right here in quadrant 3. Sine is opposite over hypotenuse, so 3/5. And it is negative 3/5. We're going down, there's my negative. Hypotenuse is always positive, and 3, 4, 5 right triangle, that's 4, but it's going left, so it's negative 4. Which tells me the sine of alpha is going to be negative 3/5, of course, because that's what he told me. But now the cosine of alpha is going to be negative 4/5, and the tangent of alpha is going to be opposite over adjacent, so it's going to be negative 3 over negative 4, which is positive 3/4. Similarly, I want to draw quadrant 4 for beta. So if I'm drawing quadrant 4, I'm going to go like this. There's quadrant 1, 2, 3, 4. So the most prominent one there is, of course, quadrant 4. And cosine is 5/13. So it looks about like this. And then if I were to draw a vertical line to the x-axis like so, and beta is going to be right here, and this is the right angle. Cosine is adjacent over hypotenuse, so 5 adjacent, 13 hypotenuse. And it's positive 5/13, so we're going to the right, which is positive. Hypotenuse is always positive. 5, 12, 13 is my Pythagorean triple here. And this time I'm going down here, so it's going to be negative 12 for the opposite side. So now sine of beta is going to be negative 12/13. Cosine of beta is going to be 5/13, and tangent of beta is going to be opposite over adjacent, negative 12/5. So just like that, I've got the sine, cosine, and tangent of alpha and beta, and I'm just going to copy that information down because, again, we're using that same for the next 3 problems. I'm going to paste it to these next 2 pages, so when we need it, we got it. So, just know that 4, 5, and 6, whatever you get there is going to be used for all 3. And this box of information is going to be very important because it's going to find everything we need to find. This tells me to find sine of alpha plus beta. That's just sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And right there we have all the information we need to do this. So cosine of alpha is negative 3, or sorry, sine of alpha is negative 3/5. Cosine of beta is 5/13. Cosine of alpha is negative 4/5. Sine of beta is negative 12/13. Negative 3/5 times 5/13 is negative 15/65. Negative 4/5, negative 12/13 is positive 48/65. As I mentioned before, even if things can reduce, it's better not to, so you get a common denominator. Negative 15 and 48 make 33 over 65. Number 5, once again, here's my box of information. We want to find cosine of alpha plus beta. That's just cosine of alpha, cosine of beta. Then we change the sign, and then sine of alpha, sine of beta. So cosine of alpha is negative 4/5. Cosine of beta is 5/13. Sine of alpha is negative 3/5. Sine of beta is negative 12/13. Again, don't reduce fractions. Multiply this, we get negative 20 over 65. Minus 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 makes minus 36 over 65. So altogether we get negative 56 over 65. As the cosine of alpha plus beta. And finally, this problem we're asked to find the tangent of alpha minus beta. And I will do it that way because if you know both sine and cosine of alpha plus beta, the tangent is sine over cosine. This requires you to actually use the tangent of a difference identity. So tangent of alpha minus beta is just going to be tangent of alpha minus tangent of beta over 1 plus tangent of alpha times tangent of beta. So tangent of alpha is positive 3/4. Tangent of beta is negative 12/5 over 1 plus tangent of alpha times tangent of beta. With the simplification of this happening, it is sometimes better to actually reduce fractions if possible. That 4 and that 12 reduced to a 3. So I end up with 3/4 plus 12/5 over 1 plus, or 1 minus 9/5. Okay. The common denominator of all the fractions here is 20, so times 20 here and here and here and here. You will get usually 3 fractions in a whole number, so everything multiplies by 20. Fractions reduce first, then multiply. Whole numbers just multiply. So 5 times 3 is 15. 4 times 12 is 48. 20 times 1 is 20, and 4 times minus 9 is minus 36. So we end up with 63 over negative 16 for the tangent of alpha minus beta. So expect on the test that that same type of thing will happen. Again, whatever you get for problem number 4 here is the same stuff we're using for problem 5 and problem 6. And partial credit grading, if suppose you get this stuff wrong, okay, I'm going to deduct points for it being wrong one time. As you work this out, this will be probably half the credits just from working this out properly. So if you get this stuff wrong and use it properly over here, you're going to get full credit for this part, you'll lose some points for that part. And then I wouldn't deduct the extra points. So again, if you do this part right based on that information, and this part right based on that information, I'm going to deduct several times for the same thing. So whatever you get for problem 4, just keep using the same stuff. Hopefully you get the right stuff though. Pay close attention to quadrants to ensure that you get the correct signs on these things. Hypotenuse is always positive. Adjacent left negative, opposite down negative, adjacent right positive, opposite down negative. It could be first or second quadrant also. I'm not going to limit myself to those 2 quadrants for these 3 problems. Number 7, another verification problem. Cosine of x plus y plus cosine of x minus y sure looks like more complicated than 2 cosine of x cosine of y. So I'm going to start on the left-hand side. I notice that both pieces of the left-hand side have that cosine of a sum and difference structure. So I'm going to change this into the cosine of a sum, so it'll be cosine of x cosine of y minus sine of x sine of y. And I'm going to change this into cosine of x cosine of y plus sine of x sine of y. And that's by number 33 on my sheet. Cosine of a sum or difference, cosine of both, change the sign, sine of both, cosine of both, change the sign, sine of both. Then, I'm going to add like terms. Minus sine x sine y and plus sine x sine y cancel. Cosine x cosine y plus cosine x cosine y makes 2 cosine of x cosine of y. Apply the identity, add some like terms, and you're done. Number 8, cosine of alpha is negative 8/17 in quadrant 2. So very much like problems number 4, 5, and 6. They're giving us information about an angle. They're telling us what quadrant it's in, so I want to draw that angle. So it's in quadrant 2. So I draw quadrant 2 rather prominently here. And I put a vector out into quadrant 2 like so. and we draw straight down to the x-axis like so, and we put the right angle there. The angle we're dealing with here is called theta. The cosine is negative 8/17, so adjacent 8, hypotenuse 17. The hypotenuse is always positive, we're going left, that's negative, there's your negative 8/17. 8, 15, 17 is Pythagorean triple. If you don't know your Pythagorean triples, then by all means the Pythagorean theorem will work. A squared plus b squared equals c squared, work it out. This time we're going up for the opposite side, so that's a positive 15. So I know the sine of theta is going to be 15/17. The cosine of theta is of course negative 8/17. And the tangent of theta is opposite over adjacent, that'd be negative 15/8. So just like that, once again, I've got this drawn properly. I can find sine, cosine, and tangent of my angle. All this information here is going to help me find what they're asking me to find, which in this case is sine of 2 theta. Sine of 2 theta is 2 times sine of theta times cosine of theta. Sine of theta is 15/17. Cosine of theta is negative 8/17. In this case, if anything does reduce, since we're not trying to add fractions, I should do it, but nothing reduces, so the best I can do is do 2 times 15 is 30 times negative 8 is negative 240. And 17 times 17 is 289. So negative 240, 289. Drawing the triangle properly, getting the correct sine, cosine, and tangent values, and then of course applying the correct identity. Once again, sine of 2 theta, cosine of 2 theta, tangent 2 theta. I'm not going to shy away from the double angle identities. It's going to be one of the three. I'm going to use this type of information to find all this, and I'm going to ask you for one of the three double angle identities on this one. Number 9, same deal. I've given you sine of alpha 7/25 in quadrant 2. So once again, we're in quadrant 2. So if I draw that correctly, here's quadrant 2, and we want to put this angle alpha in quadrant 2, 7/25. There's my right angle. Here's my angle alpha. Opposite 7, hypotenuse 25, and notice it's positive 7/25. Hypotenuse always positive. We're going up, that's positive. 7, 24, 25 is my Pythagorean triple. And since I'm going to the left for the adjacent side, it's going to be negative 24. So just like before, I've got sine of alpha, cosine of alpha. Sine is 7/25, cosine is negative 24/25. And tangent of alpha is going to be negative 7/24. All right, and I am asked to find the tangent of alpha over 2, and according to my sheet, I've got 2 choices. So I got 1 minus cosine over sine, or sine over 1 plus cosine. I'm going to go with the 1 minus cosine over sine. All right, so 1 minus cosine, that's going to be 1 plus 24/25 over sine, which is 7/25. And this is pretty common that you get to these fractions inside of fractions. So times 25, times 25, times 25. It's going to get me 25 plus 24 over 7. 25 plus 24 over 7. That just makes 49 over 7, which just makes 7. So that's the answer, 7. Once again, I'm not going to shy away from sine or cosine. If it was sine of alpha over 2 or cosine of alpha over 2, it's very important to establish the quadrant alpha over 2 is in. This is 90 degrees and this is 180 degrees. So if I know that alpha is between 90 and 180, divide everything by 2, so 45 is less than alpha over 2 is less than 90. That would put it in the first quadrant. So that tells you that sine and cosine are both positive. So if it is sine or cosine, that plus or minus, that's how you handle that. So you establish the quadrant alpha's in, and the extent of the quadrant is 90 to 180, third quadrant 180 to 270, whatever, and then do alpha over 2, that'll establish what quadrant you're in. So 45 to 90 would be here, which is somewhere in the first quadrant. So you know the sign of both will be positive. Finally, number 10, one more trig identity. Verify cosine fourth minus sine fourth equals cosine of 2x. Left-hand side, higher powers, I'm going to go with that for my less simplified expression. So cosine to the fourth minus sine to the fourth, that's just the left-hand side. Perfect squares being subtracted, so it's a difference of squares, so I would do cosine squared plus sine squared times cosine squared minus sine squared. That's just factoring a difference of squares. And then cosine squared plus sine squared is 1. And cosine squared minus sine squared just happens to be cosine of 2x. And that's going to be by number 5 and number, I think it's 36. Yep. So that's number 5, and that's number 36. And just like that, 1 times 2x is just equal, or 1 times cosine of 2x is cosine of 2x, and that's by simplifying. The identities on this test will not necessarily be, they won't be these identities specifically, but they'll be of similar difficulty. There was factoring, there was some substitution, some simplification going on. It's not going to be beyond that as far as I can imagine. But just keep in mind that, think it through. You know, maybe you save the identities or 3 of them for the last, and give yourself a lot of time to think it through to make sure you come up with the best technique for each one.